So this is nextness. So N has nextness. And then when you go to Q, nextness lost. Or no nextness. So you have now this transition from, of course, our mode of working was this. See, we had I'll put it this way. We started with N, then we went to Q plus, then we went to R plus. So from here to here, we went with going to fractions. So what we did was we started with Piano's axiom. Constructed starting with Piano's axiom, so we constructed. Then we had then we extended to equals. Then we extended this was our first exercise. Okay, so we lost nextness in this step. Okay, and then of course that the same condition persisted here, but we could fill the holes there. Okay. So the next step was at one stroke. By adjoining an element called 0 and elements minus sign for every sign belonging to we got Z. Z was minus n union then we got Q Because what we did was we started with R plus adjoint to 0 to it and to this. And then we discovered that in the bargain we get these things also. Q plus is automatically coming there, minus n is, or sorry, minus Q plus is coming there, minus n is coming. And so we get that. So whatever things we were missing there, like when we went from in n, we didn't have this because we have the binary operation. But you looked at the two equations, that is a plus x equal to b and ax equal to b. These equations were not solvable in n, in the sense that not always they had solution. In some situations they had solution. But when it came to Q plus, one of the equations we could find have solutions, like the multiplicative equation, that is ax equal to b as a solution. Okay. But still we didn't have that solution to the equation a plus x equal to b. But when it came to this next level of extension, R plus, the problem persisted and you had to discover the whole of what you call R minus, which is minus R plus, and then 0 also had to be adjoined so that you get the whole of R. So this is the situation. Okay. Then we found that we had a nice Archimedean property, starting from Q plus to, it's also available on R plus. Then what all things we lost? Of course, next test we lost. Suddenly, when you were taking Q plus, you were, you did not have the smallest element in Q plus. As one. But if you take any subset of n, but the moment we extended from n to but Q plus, does not have meaning. Because we had so if you had any element here, then you could have always got an element. So if there existed such an element P in Q plus, then P by 2 is always less than P. So P cannot be the smallest element. That's very simple. So in Q plus we lost. And in fact, we also had this property that in Q plus, given P and Q, with P less than Q, there existed a R belonging to Q plus such that, in fact, P plus Q by 2 serves the purpose. So you see there are infinitely many elements in between. So the causality is the property of and this is a transition to the world of fantasy that I was talking about. When there was nextless property, we were working on a discrete set. Now that is completely lost. Okay? And then, of course, we hope that it can be, everything can be put on a line, etc., etc. And then we were rather dismayed or delighted, I don't know what to say, to see that there are numbers like square root of 2. Which did not belong to this class. Okay? So how to catch hold of such numbers which are missing, or the positions on the line can be marked. See, the point is this: on the line you can actually, using ruler and compass, you can mark this square root of 2 between 1 and 2. How you do that? That can be done by, see, you can construct a sort of, line orthogonal to this line. This is one thing. Okay. Then use the compass to mark out one unit here. Complete draw the third side of the triangle, and then mark out this. So there exists a point through a finite set of operations using ruler and compass. One can find a point square root of 2. But then this is not a rational number. Now that's the problem. So there are a lot of entities on this line which are no more rational numbers. Okay? And how to catch out of them? Now it is for this one that Dedekind so in a very natural way, catch hold of everything using cuts. Look at the definition of cuts and how it captures these kind of objects. Then you can show that once the new class of R plus is constructed, you see that all the gaps have been filled on this half net. Okay? Or what you call on this, all subsets of this bounded above has a least upper bound. Okay? Right? In this set itself. This is not true on Q plus, because if you take this set, need some proof belonging to Q plus x squared is less than 2. Now you can show that this is a bounded set, this is bounded, but no least upper bound. What do you mean by least upper bound? Suppose you have a set, and this is something like a least upper bound. Okay. Then it says that in any interval surrounding to that, so you take L minus epsilon for any epsilon positive, then you see that there is at least, I mean, you can find an element of the set here. So that's the least upper bound. Because you know that given a set, if you call an upper bound, if M is an upper bound, then M plus 1 is also an upper bound. There are so many upper bounds available. Out of which the least one that you are taking. When you say it is the least, nothing more, it cannot be pushed backward any further. Because if you push it backward, then it will fail to be an upper bound. That is what you are saying. Because when you push it backward by an epsilon positive, that means you take L minus epsilon, then L minus epsilon would fail to be an upper bound. Okay. What does it mean? Suppose A is the given set and L is the least upper bound. It's a bounded set and L is the least upper bound. Then what happens is if you take L minus epsilon between L minus epsilon and L, you can find an element A belonging to so it is no more a upper bound format. It fails to be an upper bound. This is true for every choice of x. And this is what you mean by least upper bound. So R plus has the least upper bound property. So also when you extend it to R, it has the least upper bound property, or in other words, all the gaps have been filled. Okay, this is what you mean by completeness of the line. So it was incomplete earlier, in the sense that there were some holes. So those holes have been pegged. This is the side. Okay, so that's the least upper bound.